right. How's it going, everyone? Welcome back to the Inachus project, and we're working on more of the light up sign, so that should be good. Um, so I apologize again. I know this. People have told me that this background isn't too bad, this bright red, but I really don't like it or the lighting. So I'm still kind of working on that. I've ordered a green screen and then a black screen to attach to it as well. So I might try those out next time. It's supposed to get here Thursday if Amazon delivers on time, but we'll see. So I'll try those out, and maybe that'll help with this, or at least make me feel better about it. But if you all have any other suggestions for improving the scene, or anything, sorry, I'm a little stuffed up today too. But anyways, if you have any suggestions, just let me know. But other than that, I guess we'll get started here. As usual, I got the bounties going. I'm kind of surprised there's very little action on them, and I guess I probably need to rethink like what I'm asking for in these bounties. But if you want some Dogecoin, help me perform these tasks. All right. Well, we'll get this started again. Get the music going. So last time we left off, we finished this base. As you can see, it's all cut out and everything. I did sub the part into a company called Shapeways into their website just to get a cost estimate, and they want like 150 bucks for the part. What's going on, Atikta? Hope you're having a good Tuesday. But they wanted like 150 bucks for the part, even to print it out of basic plastic. So yeah, I was not really excited about that. So I might try and create a different version of it later that's thinner and see if that helps. I don't know if it's the size thing or a amount of material thing. But anyways, today we're going to work on the base. And what I'm going to do with the base is make it really, like, obviously it'll cover the bottom, but then the inside will it will go up in there a little bit, and that will hold a circuit board on top of it. That's the plan anyway. Whew. So we'll see what happens. All right, so I guess then, first things first, I gotta make a new part. Or did we already do this? Oh, we did make a cover. Oh, well, good. I was about to redo all that. So if I take this off... Okay, yeah. So it's still just flat. So we need to extend off of this a little bit. So let's see. Also, I didn't do a mic check or anything before the stream, so if the audio is all weird or anything, just let me know. So I guess I need to figure out what the dimensions on this are. So we'll turn that off, and then we'll go see if we can find these dimensions again. What was this? That was the screws. What was that? There we go. So 1.5 minus 0.25, so 1.25, and then 5 inches wide. Okay. And then we got to watch out for these as well. Let me take a screenshot of this then. All right, we'll close that. That looks good. All right, and the cover. And I'm actually going to turn the base off and all the other things off. Just so we can work on it. All right. Oops. And then we want a sketch there. Is it part design? Yeah, this looks right. Must be an active body object. Whatever. This is the thing that's active. I don't know why this isn't. Toggle active body. Nope. Nothing can ever be easy. There we go. Oops. No. All right, so somehow I cannot make this active or something. Oh, there we go. I'm gonna figure this out. There we go. Okay. So we need to draw something that will go, I guess, up into the base. Probably need to cut away a little bit. Like, not make it as wide as the whole thing. Because it has to fit in here. Yeah, we'll probably cut away quite a bit. And I figure we probably need like at least like an 1/8 inch of room on both sides because 3D printed stuff tends to expand and contract. And so if you make it the exact dimension, it's not going to slide in nicely like something machined. Even that stuff, you have to allow a little bit of tolerance. So we'll have to do that here. All right, first things first. I think I'm just going to go with a rectangle. And then we need to go with distances. So this is 1.5 inches wide. Like I said, we need to take an 1/8 off both sides, so that's a 1/4 inch. So, or it's not 1.5, it's 1.25 wide, and we need to take an 1/8 off, so this needs to be an inch wide. So probably just 1. And the total length is 2.5 inches. We can probably get away with just 4. That'll make sure it's small enough to slide around everything. All right, then we just got to center it. And then we know this is 1.75 wide. I guess that doesn't matter though. We can just center off the origin. Oops. So this would be 0.5. And this will be 2. There we go. All right, we'll close that. And then as far as how far to extrude it, I don't actually know. I'll have to look at that other sketch again, or that other part again. It would have been this one actually. This sketch. .75. Did we go up 1.75? Is that what happened? I think that's what that means. What happens if I change that to like 1.5 or like 1? Yep. Okay, that is what that means. Undo. Oh, that didn't work. Yeah, okay, that did work. Cool. So it's 1.75 up. This is where it gets a little tricky because we got to figure out exactly how big we need to make everything. 3/4 of an inch is probably enough to fit everything. Well, actually, we can cut down in for the circuit board, I guess. So let's figure out where we want the actual circuit board to land, and then go off that. They're not very thick. Like 0.062 inches, I think, is the typical thickness, or 1.6 millimeters. Sorry, hold on. What's 1.6 millimeters, 2 inches? Yeah, 0.062, 0.063. Okay. So that's probably a good thickness to roll with. And then the neopixels are going to be about that same thickness again. So we'll do, let me get a calculator. 0.063 times 2, which I think is 0.126. Yep. So 1.75 minus 0.126, 1.624. Let's just go up 1.6 inches and see what happens. Sorry. Just want to save real quick so I don't lose it. All right. Okay. Wow, that's a lot. Should work though. So I turn the base back on. This one. Oop. Why is it still showing sketch lines there? Weird. Okay. Let's see, which axis would it be? Z. Sorry, I just want to see like. Nope, that's definitely not it. Is it Y then? Yeah. All right, yeah, that gives plenty of space there. I think that technically covers the whole like slot up here as well. Let's see. Oh, those sketch lines are annoying. Okay, turn them off. Weird. Okay. Well. Yeah. All right. That should allow plenty of space in there. I am going to actually real quick, let's take the cover and slide it. Yep. All right, that does work. I'm surprised it's not 0. I guess we did move it around maybe. Okay. So I think that's good. So now we need to figure out how the circuit board's going to go on top of it. And from that we can get an outline. What I'm actually, I could probably go ahead and design some of this. What I'm thinking is, let's see, let me turn the space off. All right. So on this, right, we're going to have the teensy and the we're going to do, I think, just a custom little circuit board on top of this thing. That makes the most sense to me, at least. It shouldn't be too hard because it's going to be something very simple. It's just going to be the neopixels, the level shifter, and I think that's pretty much it. Or a couple caps, probably. Yeah, I would have to have some capacitors, but other than that, nothing crazy. So I'm thinking what we do is we plan on mounting the teensy board on the underside and running the wire over to that, the USB cable into it, and we'll cut out a slot here for the teensy and the USB cable. And then we'll put some mounting points that use the same screws as we've been using for like in the corners. And we'll use like 1/8 inch standoffs to hold the circuit board up off the part. That way we can just adjust it if we need to. So I think all of that, yeah, that's actually a really good idea because then we can adjust it higher or lower if it doesn't quite meet the acrylic. Okay, so I need to lower this whole thing by 1/8 inch at least, and then start there. Which means here, this one. Need to take 1/8 off of this. So 0.6 minus 0.125, 0.475. Okay. And then I need to put points for the screws to mount. So I'll probably have to go look at another sketch to see like what the ideal hole size for the screws is. I probably need to put the screws in these holes as well. Where did we do it? Probably in the base. There we go. And it would have been this last sketch. Nope. Well, yeah, it is. 56 thousandths. So that's what we'll do. Okay. For the radius, 56 thousandths. So that's just under 1/8 of an inch in diameter. Get there eventually. There it is. Okay. We want to use this face and do a new sketch. All right, then we need some circles. All right. 56 thousandths. 0.056. That's a bit too small. This one did 0.056. Try that again. 56. There we go. And then we will do, let's see. Distance from here to here. Probably want them like a 1/4 inch back from the edge. Excuse me. So that'd be 1.75. Wow, that seems kind of far back, actually. Maybe like 1.875. Do an 1/8 inch. Since these aren't going to likely be taken out later. Okay, and then from here, we did an inch, so that's a half, so minus 0.375. Okay. Just clean this up a bit. All right, there we go. And then that's going to have to drill in. So cut, and we'll do 3/4 of an inch because that's how long the screws are going to be. So 0.75. Okay. Perfect. So our circuit board will go on that. So we need to put 1/8 inch standoffs on top of it. And that's what the circuit board will mount to. And then we need to cut out a trench in the middle for where the TNC and everything is going to go. It just occurred to me too, we also need to get this wire down somehow. And out the side. It'd be nice if we could do some sort of like retention on it too. Some sort of retainer. There's parts that are specific to this that do cable retention. Something like this. The cable goes through, and you just tighten that nut down. You basically put a really big hole, put that on, and then run the cable through it. When you tighten it down, it grabs the cable, and then that'll keep it from sliding in and out. And so that way the stress is not on the electrical connection, but on the insulation of the cable, which is where it should be anyway. The 1/8 inch standoffs, because I want to adjust, like, I want to make sure I get the neopixels on the circuit board as close as I can to the bottom of the acrylic. And depending on how well that's cut and everything, that could vary. So if I use standoffs, I can easily swap them out for a different size and raise and lower the circuit board as necessary. stuff is a little tricky to do though. If you're just, let's see, for this cable retention. The way a lot of this stuff is made for like custom cables, not something they could easily slip in from the side, I guess. Maybe that's a good project idea. It's an easier to use cable retention system. So if you notice like everything here, right? All this stuff is tough to use because you can't put a connector through it, right? Like a USB micro or something. It's just not big enough. It's basically designed for wires to go through, and then you put the wires on whatever you want on the other side. So it's more of a permanent thing. I wish there was one that was like split on the side that closed. Then I could easily like put a little feature that would hold it. But I don't know if such a thing exists. Stock, active. Let's see what we're left with. Ingress protection. Would heat shrink tubing work the same with cable retention? It would. It's just not like, it's not as like specific, right? Like it can vary in thickness quite a lot. And you'd have to put like either layers of it on there or something. So, and it doesn't look as good, I guess. Depending on how you do it. I don't know how much it slides too. Nah, you still could. The plan is for it to come out of the side, so that's pretty intense. Interesting. Most of these are like enormous too. I just want like little rubber grommet pieces that I could like that are split that I can put around it and put a feature in there for. Ooh, something like this. See, that's only $38. What it takes to get decent parts these days. I guess this isn't a problem that most people are dealing with. I feel like there's a product opportunity here, though. I guess it would be the worst thing ever just to put a little, like you said, I take that, just put a little like slot there and then make it a little bigger than it would need to be and then just put heat shrink tubing on top of it. If we need to, we could find a way to come up with something there. Yeah, let's just go with that. Because I'm not getting anywhere here. I guess alternatively, I just put something down here that like can function as a clip. Oh, hold on, that might work. Give me 2 seconds. I'm trying to find an example of what I'm thinking of. Here we go. So something like this, right? Where it's screwed down, I could like leave a little space and have to and screw that into the base, I guess. I feel like that could work. I'm just worried about it being too big. Yeah. I might just have to leave this for now. Oh, wait. I might have found a better one. Okay. It's impossible to see the pictures because of the color they used. But this right here, it screws down right on that side there. So I think could make that work. 5mm max, that's a huge one. All right, so maybe I could find something close to that. Ugh. Oh, I'm tired. I don't know why. If you type the commands function, it sends to you. Really? Hold on. Oh, you're right. That doesn't work. It worked before. I promise you that. Wild. All right. Well, thank you for bringing that up. I'll look into that. See if I can figure that out. So I might have a part here that works. Oh, that's not it. That's the one I was just looking at. Like this. This seems pretty small. Doesn't have a data sheet or anything though, so it doesn't tell me how big it is. We want something pretty small. That's probably too small, but something like this maybe. That's really just the thickness of a circuit board, actually. It probably needs to be a little bigger than that. Oh, it's sent it as a message. Okay, I think I did that on purpose, actually. So yes, that is correct. That's how that's supposed to work. Yep. So if you try some of the other ones and see if they work. But yeah, it should send it as a message because otherwise it would kind of just clutter. I'm sure like everybody would like. I was planning for if a lot of people were trying to do it at the same time. So I probably need to go a little bigger than that. 2.8 millimeters, 2.39. Probably not much bigger than that. Let's try one of the random commands and see if it works. Yeah, okay, there we go. By the way, I accept Bitcoin donations. There's the address. Okay, so we need something a little smaller. How many of these are there? One of those. Two of those. There's not many of these small sizes, is there? Is 12.37 inches. Here's interesting. Looks like they all fit a number 4 screw. So that's cool, but I think I'm going to roll without this for now. It's going to be tough to fit it in there, and we'll just try the heat shrink tubing method and see where that goes. Maybe it'll work, maybe it won't. It was a fun little exercise, though, to try and figure it out. Okay. Because there will be some space between it and the wall. Maybe we could do something later. So I probably need to get the teensy dimensions. Let's see. TNC 4.0. It's always in millimeters. All right, so here it is. So we need to do a cutout in this shape and leave enough room for a USB micro connector on the bottom side for any sort of USB cable. So how big is 35 millimeters? Because that's the length. And the width is 17.78. .4 inches, so we'll just go 1.5. Leave a bunch of extra room. All right, so here's how we're going to do this. We're going to do a cut. First, we're going to do a sketch. All right, so we need a rectangle. All right, so we're going to do 1.5 inches. And then what's the width? 17.78 millimeters. Inches is 0.7. Should we just do an inch wide? Is that too big? I don't know. It might be too big, but that's okay. I'm going to try it anyway. Just don't know how much the 3D printed plastic's going to warp, so. Yeah, that's too wide. Maybe 0.8. Oops. All right. So that should be 0.4. And then from here to here. I guess that's probably a little too close. Maybe just 0.2. Good news, the green screen has shipped. Maybe it will actually be here in time. That would be useful to have. Okay, maybe start with this cutout and then do the next piece. Interesting. All right. How thick does this need to be? Probably quite a bit, actually. Actually, this was something that we should definitely err on the side of going too far, so. Tire thickness of the thing, 1.57 plus 2.5. So 3, 4, 5 millimeters. And for the sake of the cable, we should probably go a lot farther than that. I'd say a 1/2 inch. That'd probably be good. And actually, the farther we go, the more material we remove, so better anyway. So let's do a cutout, and we'll do 5. That's pretty far down. Okay. Now I have to do something for the cable. And it's probably got to be pretty dramatic. So I'm trying to figure out how to do that. Let's see. If I draw something on this side and offset it, I think I can make that work. Well, that's annoying. All right. So this is so basically what I'm thinking is like some sort of slope thing because the cable has to get down to the bottom. So I want to do just like a triangle, but then I have to put it like inside and cut out some. So let's give it our best shot. There we go. All right, got some constraints at least. I remember this needs to go 0.2 over. Oh, it probably needs to go up. Actually, you know what? This needs to go up. And then this goes over to that. Okay. There we go. And this needs to go a 1/2 inch. And then how tall is this whole thing? Did we decide? Was it 1.75? No, 1.5. Okay. Whoops. Didn't want to do that. Go back into that. Let's see. Here to here. 0.5. That should... Wow, that doesn't put us on it. Okay. Oh, because I backed it off some. I think I did like 1.4 or something. Shoot. It was 1.6, we took off a half inch, so 1.475, right? Yeah, that looks right. Okay. There we go. This is easier to think about, doing it this way. All right, the distance from here to the center should be 0.2. I like how, because of the way I'm doing it, all of the dimensions are upside down. Can I fix this? Or am I just stuck with this? I guess I'm stuck with it. All right, and then the length of that line is going to have to be 2.2. There we go. All right, supposedly that will do it. Okay, now we need to do a cutout with it, but we need to put it in the middle somehow. This whole thing is an inch wide. I think I wanted a ½ inch wide, so offset by 0.25. I don't think doesn't look like there's like an offset thing. Can I move the sketch? I think I can. What's that direction? Z 0.25. It's at negative 0.5. So if I do negative 0.25. Oh, I can't move it. It won't let me adjust that. That sucks. Okay. And I thought this was going to be easy. I thought padding you could do an offset too. Oh, I might be thinking of a circuit maker, because that's how you do it there. I don't know how to do it here then. Other than we got to get the sketch somehow in the middle, which is really annoying. Especially since it won't let me move it. Maybe it'll let me move it here. 0.25. That's the wrong way. Negative 0.25. Okay. So now it's in the middle, and now we do a cutout with it. I make that 0.5. And look at that. Now there's a place for a cable to run up and plug into a board. Probably way bigger than it needs to be, but hey. I'm tempted to put something here. You know, honestly, like this doesn't need to... go that ridiculously far. Yeah, I feel like I should leave some of the wall right here, just so it, like it's just more, it's a more solid part. Yeah, I think I'm gonna do that actually. All right, let's go change the sketch. Not that sketch. Oh, now it's impossible to edit. All right, hold on. Let's move it back. There we go. And we'll fix it in just a second. All right, so here's what I'm thinking. We got to add some extra lines. So let's delete this one. Take this one, make it a little bit shorter. We got to delete this constraint. Well, no. Put that back. Delete this one. All right. There we go. Okay. So this is going to be 0.5. Now that ½ inch of clearance. And that's to probably, we wanted a 1/4 inch, so 1.75. Oh, I guess plus points, 1.95. And then the height from here to here needs to be the same. So 0.5. So this should be 0.975 from there to there. Let's see what the easiest way to do this is. I think it's just to run it to this axis. There we go. So I think this line is constrained in. Yep, that doesn't move. Where does this go? I should be able to figure this out without having to use trig, I think. Like how long this line needs to be, because it's locked into place. It's just a matter of, yeah, 1 degree of freedom. So how high is that? So to go 2.2, we go from 1.475 to 0.5. 0.475 minus 0.5 equals 0.975 divided by 2.2. This is a rise over run kind of thing, if you remember that from algebra. All right. And then we multiply this by whatever that distance is, which is a 1/4, so 0.25. equals 0.1108, 0.1108. So it should drop 0.1108. So from here to here, it should be 0.5 plus 0.1108, which is 0.6108. Did everyone get all that? Okay. So now I close that. Then we go back and look at this. We can see that it's done. Okay, there we go. Now we have that piece in the middle there, which I really like. And now we just need to offset it, that sketch again. That attachment point. Which I think we said was negative 0.25. Yep, there we go. Now look at that. We have a place to run the cable and a ramp to run it up to the teensy. Perfect. Okay. Since we have a little bit of time now, I think we model everything else in. So we need to get all the rest of the screws, the standoffs, you know, whatever else is needed to make this work. But that part looks pretty good. So if I add in all the other stuff again, get those screws, the base, and the acrylic. Looks good. And then if I take the acrylic out, okay, yeah, you can see the slots inside there from the part. Oh, we still have to model the, we have to add the features for where the cable is going to exit. All right, so take the base away. Which way is it going? It's going down here. So over here, we have to add a little slot for the cable. This is a good, now it's gonna be a really good question here, is how big does that need to be? Maybe a 1/4 inch? That's probably too big. I feel like an 1/8 is too small, but a 1/4 inch is too big. Let's see here. Yeah, 1/8 is too small. But a 1/4 is too big. So what's between? 3/16? What is 3/16 in decimal? 0.1875. Yeah, I think that works. We'll do 3/16. I actually don't think we need to do anything to the base, probably. Oh, no, we might need to. Hold on. 0.1875. Yeah, we would need to. All right. So let's take off this piece. And then we'll put a sketch here on this one. Cancel. Got to somehow figure this part out again. Ah, come on. How hard can it be to add a sketch to something? All right. There we go. All right. So on this edge over here in the middle. So how do we want to do this? Line, 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 and then a nice little arc. There we go. And then radius, we said 3/16, so 0.1875, so divide by 2. Actually, that's going to get really weird. If I do this instead, and do this as 0.1875. Okay. And then this distance needs to be half of that anyway, so I guess we do have to do. Point 0.9375. Okay. All right, perfect. And then we just got to get this lined up right. So right in the center. I think it's 2 inches from here to here. Yep. Ah. I need to put that same constraint over here on this one. Oh, 9375. Why didn't that work? Oh, because I didn't do a tangential constraint. Let's see if deleting this does that. So from here to here. Oh, and then here to here. There we go. Yep. So that just can only move up and down at this point. All right. Five divided by 2 plus this equals from here to here. Well, the number I got is wrong. I think. I don't remember. I thought the thickness of this base was 1.75. Oh, I did. Okay, I know what I did wrong. Yeah, the easiest way to do this is just half of 1.75. So from here to here. All right, that looks correct. Let's close that. And then we'll do a cutaway with that. Perfect. And then I'm going to go overboard and add a little feature on the base to kind of go in that as well. So let's go turn on the cover. There it is. Let's see, I can turn the bass off. So cool. I guess this sort of works. That is the side. Okay, cool. All right. So what we're going to do is we're going to do this. Go over here. Go down here. Xometry. No, I've not. I've looked into shapeways. Oh, I got caps lock on. CNC machining, 3D printing, injection molding, sheet metal, urethane casting, materials. All right, cool. Oh, they've done stuff for GE, NASA, Bosch, BMW, Dell. Okay. I will tell you right now, this sounds expensive, but I don't know for sure until I put a quote in. Maybe because they do a lot of stuff, they can just do it easily, fast, and cheap. Oh, and they're ITAR registered, so good. We won't be violating international trade arms agreements. Yeah, I'll look into them. Let you know what I think. I'm not totally optimistic yet, but we'll see. Oops, no. There we go. Okay. Let's do some tangential constraints. Yeah, we got to make sure important consideration. Make sure we don't violate any arms agreements. Don't want to become a war criminal while doing this. Or something. I don't think that counts you as a war criminal, but either way, it'd be bad. Let's see. Okay. .1875. This one's gonna be a little tricky. I should not make it as wide as I'm going to, but this is really hard otherwise. All right, and then distance from here to here should be a 1/4 inch. Always a typo. Let's see, that looks good. And then from here to here, it's going to have to be 0.09375 or 93.75 thousandths. There we go. Perfect. All right. And then extrude that a 1/2 inch. Other way. Actually, we should just go all the way to the base with it, shouldn't we? Nah, let's stick with less material. Okay, so that's a cool little feature that would be really hard to print. Honestly, that just needs to be tapered way down. I might be able to add a around the edge or something. Select a fill. I wonder what this looks like if I select it. If I can select it. That one. All right. Fill it. Where'd it go? Failed to create fill it. Cancel. Yeah, I didn't like that apparently. I might have to take this feature out eventually because that doesn't look like it's going to work very well. Or at least I'll have to edit it. Maybe I just need to go ahead and do that. How much time we got? Oh, we got time. Absolutely. All right, so that constraint needs to get deleted, and this one needs to get deleted. Okay, and probably this one too. Yep. This probably needs to stay in the same spot that it was in. So 0.09375. And then the radius of that. Needs to change. Oh, 93.75. Okay. How does that move? It doesn't, but somehow it's not locked in. Interesting. Delete this, and then I'm going to delete these. All right, let's do a line from here up to here, and then from here to here. There we go. All right, and then that constraint goes there. And then basically we can do something like that now. So we need to set that height. I'm thinking we go halfway. So we go from here to here. And we do 46.875 thousandths. Same from here to here. Okay. And we have to do this distance again. 0.25. All right, somehow we still have a degree of freedom. Oh, because this can move. Yep. Okay. So from here to here, that is the 93.75 thousandths. There we go. And then close that, and it'll redraw that, and then we'll see that it's not pointy. And it's actually, whoops, arguably printable. And then if I turn on the other one, the base, that fits right around that. So that'll slide in nicely there, and we can put a little retainer there for the, what you call it? Oh, cable, yeah, cable retainer. All right, so that looks good. So now I want to start adding the other screws and stuff in. So I guess we need to go through and duplicate this a bunch of times. Four, 5, 6, 7, 8, 9. Sheesh. I'll rename these two then, so they all have the same 00 number. And then move this cover down to the bottom. Can I please do that somehow? Nope. Can you not reorder things? I guess not. Well, that's unfortunate. All right. So we just got to change the placement of this. All right, so come down on the Y a bunch. There it is. And then let's go out on the Z a little bit so we can see where this is. So if I do -2 on the Y, what does that put us at? Okay, so that's right at the edge of that part. So it's measured from the top of this square piece of the base. I know there's a 1/4 inch thick, there's a recess halfway in, so it probably needs to come down 2 1/8 inch. So 2.125. Okay. This is going to have to be me remembering all of those dimensions to try and get it in the right spot. Probably could go ahead and orient it though. Axis. It's on the Z. Change that to 0. Change which axis does it need to orient on? Oh, is it Z? No, it's X. It needs to orient on the X. 1. Whoops. And then angle 90. There we go. I probably should have copied it, all the others from this one, honestly. Because then at least some of the settings would have been right. I'm just going to do that, actually. All right. Delete all that. Okay, now we just need to move this over and then slide it up into position. So X would be from the middle. This thing was 5.5 inches wide. So 2.25 minus 1/4, so 2 inches to the hole, I believe. Probably. So if I change this to 2, no, 0.5? Really? Is that what we did? Okay. Oh yeah, that does make sense. All right, and the Z, 0.75, back a 1/4 inch from each side. 0.25. That's the most complicated one, actually. Let me go find a sketch. I think it was this one. No. This one? No. No. I should probably start like labeling these things that actually make sense. There we go. 2.5 over, 0.625 down. Okay. Oh, come on. 0.625. That didn't do anything. Why not? I put it in the wrong spot. Where's 0? Where's the origin? Oh, it's right there. Okay. Wow. So that makes at least a little bit of sense. The origin's in a weird spot. I think I put it a 1/4 inch back. So 0.25? Yep, that's correct. And then somehow, am I just not lined up? Oh, I'm just not lined up. Okay. And then I think it needs to go up a bit on the Y. It's 3/4 of an inch. I need to do half of that, I think, because it's from the center of the screw. 0.75 divided by 2 equals 0.375 minus 2.125. So this should be negative 1.75. There we go. So that screw fits nicely in there. And now I just need to do that for all of them. So let me duplicate that a couple times. 2, 3, all right. This one, so 0.25 plus 1.2, so 1.5. Cool. This one we're going to leave there, but we're going to go to the other side. So we're going to do negative 0.25 or negative 2.5. So it should be down here now. Yep. And then the last one, 5 and negative 2.5. Okay, cool. Just to double check, turn the base off. And yep, they're coming up there. All right, looks good. I need to figure out how to color these parts again so I can make things... Oh, I think I tried that before and I couldn't get it to look right. I do remember doing that now. Okay. Now I need to do the same thing. Where is it? This face. I need to do it for these screw holes. But I need standoffs, actually. So make master. Stainless steel spacers, hopefully not too expensive. Let's see what we come up with here. I think I was going to do an 1/8 inch thick. And then I need to do at least a number 4 screw size. Probably should do a 6, honestly, because the screws I'm using, the threads are bigger because they're designed to eat into plastic a little bit. So what's a 6? Yeah, 1.4. Yeah, I should definitely do a 6. So what's the smallest I can get? That excuse me. I'll just do 1/4 inches. That's pretty straightforward, right? $1.22 each. That's kind of expensive, but not horrible. You know what? Let's see if the aluminum ones are cheaper. So $1.22 for that. Because that was the other option here, right? Was aluminum. Although I guess I could just use plastic ones. Those might even be cheaper than that. You can get titanium. Polycarbonate. To expand. Interesting. Well, I want to see what the cost of aluminum is. Number 6, 27 cents each. That's a lot cheaper. We're definitely doing that. All right. File, import. There it is. Okay, let's rotate this. Needs to rotate around the x-axis. There we go. And then I need to figure out this thing again too. I'm gonna turn off these other screws. I want to get to a point where we can basically start designing a circuit board next time. All right, I guess I need to figure out for the cover one of these sketches. Oh, that's it. Okay. Let me take a picture of that. All right, I don't know how far up this thing is too. Oh, yeah. Okay, so we need to go. Give me a sec on this one. I believe it's a 1/2 inch up on the Z. I don't know why it keeps doing that. If you consider doing a how to make your own series, I thought that was what I was kind of already doing. Oh, I've got the wrong thing selected. I need to select this. Thank you. .5 0.5. I think that's right. Okay, yeah, that is. I basically, like, there's these kind of things that I make. I already see them out there. I just like, you can buy a little light up sign for your desk that uses acrylic like this. It's, and it's not that expensive either. What I do is figure out how to make things that something yourself that a company already makes for a lot more money and a lot more stress. like, because they make it volume, so it's cheaper. But I get to at least get to learn how to do it. Okay, and then 1.875 on the x-axis. There we go. And then I need to settle it down on the part. I don't remember. What's this one? Okay, this is the part that no, that was the first part of the base. That was the cutouts for that. A little farther. There we go. I need to know how far up that went. $1.475. So this needs to go down to minus 1.475. Hang on, just look at the calculator. Okay, 0.525. If you had something different in mind for like a how to make your own kind of series, for the how to make your own series, let me know, because I'm really interested on what your thoughts are on that. Zero point 525. Ah, so the origin point's in the middle of that. So I need to subtract a 1/16 of an inch from it. So 0.125 divided by 2 plus 5, so 0.5875. Oh no, I did that wrong. Minus negative 0.4625. Oh, single stream projects. That's not a bad idea, actually. The problem is like, I mean, it takes a long time to do this kind of stuff. There's a reason, like, if you look at most engineering, like YouTubers and such, they only put out videos once a month, really at most, at least the really successful ones, right? And the reason for that is because what they do takes so much effort and time. And most of them are working on that stuff for months or even years. And it's all scheduled and backlogged, right? They're working on multiple projects at a time. I actually really like that idea of doing like single stream projects. The problem is just making them simple enough so that you can do them in a single stream. If you have any ideas, though, I'm definitely all ears. I'll try and think of some too. All right. So I need a few more of these. Oh, it replaced the... Wait, what? How does that even work? That's the wrong part number. See, it's changing the last digit. That's really annoying, actually. The part number is... Hold on, I'm looking for it. 92510A440. Okay, so that is correct. Let's rename this. All right. And now let's do it. Much better. Okay, so on the Z, we did 0.5. And then we need so 0.5, 0.375 plus 0.375, 1.25. Ooh, spam call. Those are my favorite. It's probably my car warranty. $1.25. There we go. Then this one goes do 0.5 and do negative on the X. There we go. And this one goes 1.25 and negative on the X. Okay. So now all the standoffs are in the right place. Yeah, we left way too much room for that TC, but that's all right. So it makes it all good. Answer it on stream. That is a great idea. That's a horrible idea. All right, almost done. Need to make some more of these screws. Actually, I probably should only start with one. Okay, let's go 0 on the Z and see what happens. Where is this? There it is. So we need to rotate this one like all the way around. So it's at 90, so it needs to go to 270. There we go. And then Z is 0.5. Y 0. Where does that put it? All right. And what is the placement of this? The Y is negative 0.463. What was it actually? Negative 0.4625. So if I go to this, negative 0.4625. So that's not enough because it's to the center of the screw. To the center of that. I need to go to the top of that. Okay. We go 525. That puts us at the center at the top of this thing. That's an eighth. So 0.75 divided by 2 minus 0.125 means it needs to go down just a quarter inch. Oh no, it doesn't. It needs to go less than that because of the board thickness of the circuit board, which is going to be 0.062. So it needs to go down 0.188. It's at negative 0.525 plus 25. So it needs to go to 0.713. Negative 0.713. Sure. And then it needs to slide over to that, which is on the X, which was 1.875. There we go. All right, now let's make 3 more of those. Then 0.5, and then 1.25. No. positive. There we go. So check that out. That's where the circuit board's going to go perfectly. And all the screws are in the appropriate spots. So if I turn the cover off, we should be able to see them all inside. Hopefully not hitting anything. Yeah, it looks like there's room. Just barely. Just barely. Wow, okay. Where does the acrylic land? I guess I didn't even think about that. Oh, it's way up in there. We might have to extend that down a little bit. To the bottom of this for the sake of hitting those neopixels. Yeah, I might do that real quick, actually. Looks like it needs to go another 1/4 inch or so. Probably. Nope, not that one. $4.75. Wow, that is literally like as close as it could be without touching. Perfect. We can always raise that up some if the neopixels are taller than expected, but they're pretty tiny, so I think we'll be okay. And then we'll put all the other parts on the bottom of the board. We'll have the caps too, but we'll be able to double check all that, make sure it lands in the right place. Cool. Hopefully this works. If it's just like lights up, it doesn't really do a good job of lighting it up. It'll be kind of tricky anyway, because you have light coming in here, but then it's dispersing. I don't know what that's going to do. No, screw holes are in the same spot. So if I turn the base on, you should be able to see here that there's a hole all the way through, so it still lines up. Here, I'll cycle this. So yeah, that should still be good. That's the beauty of the way you can modify sketches in these things. You can change one dimension and fix a small thing without anything else moving, which is great. Sweet. All right. I think that's probably good for tonight. Next time I will, I guess we'll start making the circuit board next time. So that'll be cool. And it shouldn't be too complicated either. I say that now. It might be really complicated. And then we just got to find a cheap place to make these. We need to figure out, too, if the cost of these things is determined based on volume or, like, complexity. Or, like, just overall dimensional size. I'm curious what this cover is going to be. Here, if I go select the cover, export. I'm just going to try this real quick because I want to try it. All right, get a quote. Let's see what we got. Based on weight, at least based on the research. So I think the amount of material then, right, is the thing. Regardless of like how big it is. Anybody want to take a guess here before it pops up? $73. Nice. Oh, we can print it out of aluminum starting at $1,200. Oh. What's that one you sent me? Let's try this, see what they say. Oh, they require an email. Oh, yeah, no, I wouldn't 3D print the lightsaber help. I'd get that CNC'd. All right, this requires a phone, or apparently it always requires an email address, because why not? All right, let's see what we got. Take a bet. Is it going to be higher or lower than the $73 or whatever? I think I also... Higher? You think so? Okay. It was. Well, maybe. They have more options. So the mid-range, so the economy is lower, but everything else is higher. So if you're okay with waiting a week to get it, which is perfectly fine, then it's only $65. I guess you were technically right, though. It was kind of higher for the standard. What's the difference between these two? The standard and the expedite? They ship on the same day. Let's try CNC machining. Can you not see? Oh, here we go. ABS. Black. Sure. Oh, 260. Wow, 260 to machine it out of plastic? All right, one more. Injection molding. For when you're trying to make a ton of stuff at once. This is not good at small quantities. Yep. So yeah, you have to do, the minimum quantity for that is 50. Oh, and it can't be instantly quoted. Because they're, oh yeah, because of the complexities, because you can't actually injection mold it the way it is. Well, you might be able to, but it'd be really hard. Interesting. All right, that was fun. So, long story short, it's really expensive, and I gotta figure out a way to make it. Not sure on that one yet. Yeah. I designed the part to be 3D printed. It's not designed in such a way that you can injection mold it. And CNCing is, you can do it. It's just you need quite a few axes if you don't want to have to place the part multiple times. I'll have to think on that. I wish I just had my own 3D printer. That'd be easier. All right. Well, thank you all for joining me tonight. I am going to sign off. I'm hungry, but we got a lot of good stuff done, and I can start on the circuit board next time. So I will see you all later.